capacity pooling, flexible manufacturing. The last type of um, pooling, risk pooling strategy that we will consider in this topic is actually very different from all the others because rather than pooling the demands together, we will be talking about adding flexibility in the production side. So we will consider here the following stylized situation faced by a company. Again, right, the example is designed so that we can easily do the calculations and see the benefits. So imagine we have 10 plants that make vehicles, and there are 10 vehicles to produce. Each plant has a capacity for 100 units per time period, I don't know, per week or something, right? We will not define the period. And the demand for each vehicle is normally distributed with the mean that matches the capacity of a single plant. So mean is 100 and standard deviation 40, right? And we assume demands are independent. Now, each plant, this is the interesting part, can be configured to produce any of the vehicles. So it can be configured to produce one vehicle, but it can be configured to produce more than one, two, three, or up to all vehicles. But flexibility is expensive. So cost to construct a plant is increasing in the number of vehicles that it can produce, right? If it just produces one vehicle, it's cheaper than if it could produce two vehicles, and the plant will be more expensive. And increasing the number of variants will basically increase the cost of this plant. So the company must decide which plants can produce which products before demand is realized. And after that, when demand is realized, the company will try to allocate the capacities of each plant to satisfy the demand, right? But of course, it all depends on the amount of flexibility, right? And if demand exceeds some total capacity allocated to a particular car, the sales will be lost. And if demand is smaller than capacity, right, that is allocated to produce this variant of the car, then the capacity will be idle. So both ways there is some kind of loss. So here we see four possible configurations of the plans, and the links here indicate whether a particular plant can produce a particular vehicle. So one extreme case is if a plant, right, is allocated to exactly one vehicle, so there's actually the least flexibility possible. Each plant is configured to just produce one type of vehicle. We have plants 1 to 10 and vehicles A to J, right? And there's no flexibility, right? We could, of course, add flexibility. So we could, for example, say, oh, plant 1 now can also produce vehicle B. So it has minimal flexibility. We have 11 links now, right? Only plant 1 has a little bit of flexibility. Of course, we could keep adding those links in some random fashion, right? This is some example of 16 links. And, if you want a total flexibility, which would be the most expensive, right? Example, this is the least, this is the most. The total flexibility, each plant could produce each vehicle, but this would be very expensive. So the key advantage of flexible manufacturing is that flexibility allows for shifting production to high-selling products to avoid lost sales. So if you consider a smaller example of just two plants and two vehicles, right? And there are two configurations that you see here in this picture, right? One has no flexibility and the other has total flexibility. So no flexibility, one can produce only vehicle A, plant 2 only vehicle B. Total flexibility, both plants can produce both vehicles, right? So imagine that each plant has, again, capacity of 100, and let's say demand turns out to be 75 for A and 115 for B, right? So in this one, of course, plant A1 will be underutilized because A, we only demand 75 units of it, right? So plant 1, in this case, will make only 75 units and there is nothing else it can do. It will be idle for the remaining 25% of its capacity, right? Whereas plant 2 will make 100, but the demand is 115. It could have made more, but of course it doesn't have the capacity. And so on one hand, for the first vehicle, we have the too much capacity that is underutilized, and for the second vehicle, we have lost sales, right? And the utilization will be 87.5%. 0.5% and some lost sales occurs, right? And in the total flexibility, in this example, the utilization will be higher because plant 1 can make 75 units of vehicle A, but also can make the shortage for plant B that plant 2 cannot cope, sorry, vehicle B that plant 2 cannot produce. So a total plant 1 can make 90 vehicles now, right? In this example, because the total demand is actually less than 275 and 115 is just 190, we don't have any lost sales, right? The total demand is lost less than total capacity. But the important thing to realize is that regardless, we actually managed to improve utilization, and because of this, capture a larger fraction of the sales when we have this flexibility, right? So to see the benefit of flexibility, we can look at right this chart. This chart shows you what happens if you have no flexibility. What will be the expected capacity utilization, right? With the 10 plants again, we're back to 10 plants and 10 vehicles. And what will be expected sales? Remember, we have 10 vehicles, each of them average demand will be 100, right? So expected sales in terms of number of units are shown here on this axis. And of course, those numbers, both of them, utilization and expected sales, will actually grow as we add more flexibility. But the interesting thing is that the total flexibility, when we have 100 links, right? Each plant can produce each vehicle, which gives us about 96% utilization and 960 expected sales. Notice we will never reach 1,000 sales, but I mean that's of course the feature of the system. Even if we have 100% flexibility, the expected sales will always be smaller than expected demand. So what is important to see is that total flexibility, which has 100 links, is not much better than the case of 20 links, but those 20 links must be added in a very specific way, right? So as we add the links, if we add them in a smart way, we improve utilization and improve expected sales. And when we get to 20 links for 10 plants and 10 products, we can get to a level that is very close to total flexibility, so gives us almost the same benefits. So how do we add flexibility in a smart way? And the answer is create large chains. A chaining of flexibility is shown here. So of course we have here in this picture the case of 100 links, total flexibility, and we say it will be very similar in performance to the case of 20 links, where 20 links are added as one chain. And the way this works is that we have vehicle A, which can be produced by plant 1, but also plant 1 can produce vehicle B. B can also be produced by plant 2, and 2 can produce also vehicle C, and so on, right? So this is actually creating one chain, right? Where when we get to vehicle J, which can be produced by plant 10 can also produce vehicle A, and you see it becomes one, like a cycle, right? One chain of all connected vehicles and plants. And this is another way to add 20 links, but actually much inferior, because here we have chains where only 2 plants are able to produce 2 vehicles in a kind of total flexibility, but they are separate system from plant 3, 4 producing vehicles C and D, right? The reason for this working better is that, if suppose here the demands for vehicles A and B are very small, or smaller than 100, whereas the demands for vehicles C and D are larger than 100, maybe not much larger, in this not much smaller. Here in this chaining effect, we can actually shift somewhat the capacities of 1, 2 to produce demands for demands C and D, because there is this connection 2 to C, right? Which is missing in this example. So basically, if you can create large chains where right, each plant is able to produce 2 vehicles, but in such a way that they are all connected in one chain, when you know the demands, you can satisfy the demands to a much larger extent for those vehicles with one long chain than with some other configurations. So I showed you that flexibility can help us capture more sales and so increase our revenues and profitability, improve utilization, right? When we add it in a smart way, when we add the 20 link chain for a configuration of 10 capacities and 10, 10 demands. But when is it actually most valuable to use flexibility? Well, as it happens, it is most valuable when the total capacity is roughly equal to expected demand, which was in case in our example. We had a total capacity of 1,000 and total demand of 1,000, expected value of the demand 1,000, right? And so this was the case in our example, and we saw the benefit. It actually, flexibility is least valuable when there is a big mismatch. Either capacity is much higher or much lower than the total, I should say, expected demand, right? When it is much higher or much lower, then the benefit is much less. And you can see it here on this chart, right? So here, expected demand in all cases is 1,000 units, and the total capacity C is what varies. And you see the case of C1000. This is the case, C1000. When we have no flexibility, this is the blue line, and the red line, when we add 20 links, one chain, what's the benefit in terms of utilization and expected sales? So you see from this point, we go to this point, the benefit is great if we add flexibility, right? What you can also see here is that if, for example, capacity is 1,500 in total, so like 50% more than the expected demands, then the benefit will be very small here, right? We will not increase the expected utilization or expected sales will increase just a little bit when we go to 20 links. Or here with capacity 1,250, right? We have 25% more capacity than expected demand in total. And there is a benefit, but less than in this case, right? Utilization and sales increase only a little bit. And you see here in this side, on this side of the chart, when capacity is actually much smaller, for example, if capacity is 500, right, the expected utilization and the sales will increase much less than in this case. And why is it, right? Because if you have a lot of capacity, then you already over provide for each demand. So each factory with no flexibility would be able to satisfy the demand. If each plant has 150 capacity, it is very likely that it will satisfy with all the demand, which has mean 100 only, right? 150 capacity for expected demand 100. That's also already going to satisfy most of the demand. So the sales will be close to the demand. And similarly, or actually on the opposite side, it's not similar. When the capacity is much lower, right? Capacity is only 50 for each plant with a total 500, right? When the demand for each product is 100 expected value, then we are very unlikely to satisfy, to actually produce less than 50. All plants anyway will be probably at full capacity, so utilization will be close to 100%, but anyway we will sell about 500 units. And if you add flexibility, it is not going to help you because all plants are anyway fully utilized now and they are not able to produce much more than this, right? These results were obtained through some simulation. So you see the benefit on this chart is when capacity is similar to the total demand, total expected demand, this is where we have the highest benefit of flexibility. And as we go away, one way, much more capacity or much less capacity than expected demand, the flexibility is least valuable, right? So one more interesting observation that you can see in this chart is that either you can improve capacity or you can add flexibility. So increase capacity or increase flexibility can give you the same benefit in terms of expected sales and because of that expected revenue and profit. And what I want you to see is if you consider a starting example, if you are here at this point, you have capacity 1000 and right, no flexibility. And we have two options to increase our sales significantly. Either we can add flexibility and we can get to sales of about 950, right? When we add 20 links of chain, 20 links of in one chain as flexibility, right? But the same benefit we could achieve by increasing capacity to 1,250, so improving by 25% capacity in all plants. Because you see, remember, utilization is not the goal. The goal is the sales, because the sales bring us revenue and give us allow us to make some profit, right? And notice this point is roughly on the same level as this point. So from this perspective, if you are at this point with capacity 1,000, if it's cheap to add flexibility and increase your sales, right, to this level of about 950. But if it's cheaper to add capacity instead of flexibility, right, then it's better to move to this point. And here we have no flexibility. Again, each plant produces one product, but right, one vehicle, but each plant has now an extra 25% of capacity, right? So notice that there is a kind of a choice here, right? If flexibility is cheap relative to capacity, add flexibility and move from this point to this point. However, if flexibility is expensive relative to capacity, then instead add to capacity and go to this point here.